This is a velocity time graph. We've got velocity at the side here, and you can think of that as being speed, and we've got the time along the bottom here. From any velocity time graph, there are two things that you can immediately work out: the acceleration at any given time and the total distance travelled at any given time. The gradient gives the acceleration, and the area under the graph gives the distance travelled. Let's look at finding the acceleration now. On this particular graph, we've got three different accelerations. This part here, then this, and then this part here where it's actually slowing down. Acceleration is measured in meters per second per second. We prefer to write this as meters per second squared. Let's find the acceleration for this section of the graph here. We know that the acceleration is given by the gradient, and we know that the gradient of a line is given by the change in y divided by the change in x. Now the change in y for this section here is positive. It goes from 0 to 12, so the change in y is positive 12. The change in x is also positive. It goes from 0 to 6, so the change in x is 6. So the acceleration is given by 12 divided by 6. This is 2 meters per second squared. If we look at this section of the graph now, we can see that it's horizontal. That means it has no gradient, so the acceleration is 0 meters per second squared. That means that here the thing is travelling at a constant speed. In this section, the object is slowing down. We can see that this time the change in y is negative. It's minus 12. And the change in x is still positive. It goes from 16 to 24, so that's 8. So the acceleration here is minus 12 over 8. That's minus 1.5 meters per second squared. We're now going to look at calculating the total distance travelled. This is done by calculating the area under the graph. Now I can find the area here in two ways. I could see that I've got a right-angled triangle here, another right-angled triangle here, and then a rectangle in the middle. I could find the three separate areas and add them together. However, it's much quicker to notice that this is parallel to this, so we've got a trapezium, and we know the formula for finding the area of a trapezium. So the area is given by a half a plus b multiplied by h. So we've got a half times a, which is this distance here, and that's 10, plus b, which is this distance here, and that's 24, times h, which is the height, and that's 12. So I've got a half times 34 times 12. So that's 17 times 12, and that's 204. Now, because the velocity was given in meters per second, we know that the distance travelled is 204 meters. Here's a question for you to try. Press pause and have a go. When you're ready for the answers, press play. Here are the answers. For part A, you should have worked out the area under the graph and got 228, so the distance travelled is 228 metres. For part B, you just needed to find the gradient of this part of the graph here, and that's 3, so the acceleration is 3 metres per second squared. Now this is a harder type of question because we've got non-constant acceleration. What I mean by that is that in this section here where we've got a straight line, we have constant acceleration. However, here, where we've got a curve, the acceleration is changing all the time. We're being asked to find an estimate for the acceleration at 2 seconds. So that is at this point here. So what I really want to do is find the gradient of the graph at this point. To do this, I need to draw a tangent to the curve. Like this. If you draw the tangent accurately, you can see that it gives you the gradient of the curve at this point here. Remember, to find the gradient of this line, we need a change in y divided by a change in x. So what we need to do is draw a right-angled triangle using this line or part of it as the hypotenuse. For example, we could use this, or indeed any other right-angled triangle. I'm going to use this one here. The key to finding this gradient correctly is working out what each little square is on the scale. I can see that this scale is the same as this scale, and that we go from 0 to 2 in 5 little squares, so each little square must be 0.4. I'm going to use this now. So I want to find the change in y. I can see that I'm going from 6 to 12, so that's 6, and then approximately one more little square, which we know is 0.4, so that's going to be 6.4. Now for the change in x, I'm going from 2 to 6, so that's 4. So the acceleration is 6.4 divided by 4. And this gives us 1.6 meters per second squared. You should get approximately the same answer even if you use a larger or smaller triangle. Here's one for you to try now. I want you to find an estimate for the acceleration at 6 seconds. To help you do this, I'm going to draw the tangent for you. That's here. And to help you even further, I'm going to give you the triangle to use as well. That's here. Remember, you need to find the gradient of the tangent. Press pause and have a go. When you're ready, press play. You should have an answer of 0.6 meters per second squared. Now we know how to find the acceleration at any point in the journey, and we know how to find the total distance travelled. But this question is asking me for the average speed. How am I going to work this out? Well, I know that speed is the distance divided by the time. I know that the time taken is 24 seconds because that's here. I can work out the distance travelled by calculating the area under the graph. The only problem is that we've got a curvy part to the graph, so this makes calculating the area under it a little bit more difficult. Now, fortunately, they've only asked me for an estimate of the average speed, so this means I can have an estimate of the distance. So I'm not going to count every single little square. Instead, I'm going to try to cut up the area here into manageable pieces. My first manageable piece will be the area under the straight section. So that's here, and we can see that we've got a trapezium. Now for the curved section, I could do a triangle, but if I find the area of this triangle, I'm missing out quite a large bit on this particular graph. So instead, I could go for another trapezium here, and then a triangle. This would be fine, and I'd get all the marks for this. But because I'm a perfectionist, I can see that I could do yet another trapezium here, and then a small triangle on the end. This gives me 4 sections, 3 trapeziums, and a right-angled triangle, and I can find the areas of each of these sections. So I'm going to start by finding the area of this trapezium here. Now I want to find the area of this trapezium here. It's a little bit more awkward than the last one because the parallel sides are here and here. So this time I still have the same formula. I still have a half times, but this time A is this distance here, that's 10, and B is this distance here, that's 12, and H is actually this distance here, that's 8. So I've got a half times 22 times 8, that's 11 times 8, which is 88. Now I do this trapezium in a similar way to this one. I get 32 for this area. The last thing I need to do is calculate the area of this right-angled triangle here. I get 6 for this area here. So remember, I'm trying to find the total distance travelled, and that's the total area. To do this, I add all of these together. I get 222. To find the speed, I need to divide this by the time. The time is 24. Using a calculator, I get the answer 9.25, and the units for this will be meters per second. Just out of interest, the tricky part of this question was finding the area under the curved section of the graph. I've done it in 3 sections. The more sections you use, the more accurate your answer will be, but you could get away with just doing 2 sections. As long as your final answer is reasonable, you'll still get all the marks for the question. Here's a question for you to try now. Most people would split up the curved section in this way. Press pause now and have a go. When you're ready, press play. Here's the answer. Now this is a much more difficult looking question because we don't have a graph. However, if we can work out how to draw our own graph, then that will make it into something that we can do. I'm going to use a line-by-line approach to drawing the graph. The first line tells me that a car has an initial speed of u meters per second. This tells me that it's going to be a velocity time graph. So I'm going to have velocity here and time here. And the initial speed of the car is u, so let's say that's about here. It accelerates to a speed of 1.5 u in 8 seconds. So 1.5 u is about here, and the car's going to accelerate to that speed in 8 seconds. The car then travels at a constant speed of 1.5 u for 16 seconds. So it's going to travel along like this for a further 16 seconds, which will take it to 24 seconds. The next line says, assuming that the acceleration is constant, which I have because I used a straight line here and here, show that the total distance in meters travelled by the car is 34 u. Now I know that the total distance travelled is the area under the graph. So what I've got to do is calculate the area under the graph and hope that it comes out to be 34 u. I can see that the area under the graph is already split into 2 convenient sections. So I'm going to do this part first. This is just a rectangle. So this distance here is from 8 to 24, so that's 16. And this height here is 1.5 u. So the area is 1.5 u times 16. 1.5 times 16 is 24, so that's 24 u. Now for this area here, I've got a trapezium. I've got 2 parallel sides here. This one has a height of u, and this one has a height of 1.5 u. So the area of this section here is given by a half a plus b h. So that's going to be a half times u plus 1.5 u times h, which is 8. So that's a half times 2.5 u times 8. Now, to make this more straightforward, I can do the half times 8 first, which is 4, and then times that by 2.5 u, which gives me 10 u. So the total area under the graph is 10 u plus 24 u. And that's 34 u, which is what I was looking for in the question. Remember, when doing a question like this where you're asked to show the answer, you must make sure that you show all of your workings because it's this that gets you the marks. Here's one of those for you to try now. Press pause and have a go. When you're ready for the answer, press play. Here's the answer.